Recording. All right, Zoomers, can you hear me and see me and everything? And the yellow and purple? Okay, here come some more Zoomers. You won't be lonely in the Zoom room. Hello, roomers. The two faithful attendees who sit on opposite sides of the room, so I get to do the swivel action here.
We're gonna make sure we keep your neck muscles nice and
Yeah.
loose.
Yeah, well, you know, it's important as you get older to maintain your flexibility and strength. So you're just doing me a favor. I understand. Thank you for your efforts in ensuring my health. I appreciate it. All right, we're not at spring break week yet, but we're very close. So we're in week 7 here. As I mentioned just a minute ago, but for the recording, I did update grades this morning. So if you turned in homework 2, you should be able to see how that went. Not everyone completed it, so I can't go over it as a group, but I will be happy to answer individual questions. Let's see, over the weekend, I put up example 4B, which is going to take a while. This is the one that is using structural equation modeling to do various extensions. So what we have in the remainder of example 4A is standard structural equation modeling for the same models that we can do as multi-level models. The 4B extends that into things that only SEM can do, including latent basis models, growth of factors, and I added something this year. We're going to have curve of factors and factor of curves. Those are 2 different models. I only had time for one of them last time, but we're going to make time for both. So if you haven't grabbed those files, I'm hopeful to start them on Thursday, but we'll see how long things take as usual. Let's see, next thing you have to be working on is your project outline. Any questions on that? Do we all have a plan? Are we going to have a plan by Monday? Okay, at least some variables. You identified a data set, some variables, some research questions. That's like, I can help you figure out what kind of model or what example would be closest, but I just need the stories. And if you don't have enough information for me to do that, I will ask you to revise it and send it back in. So once I look at those, I will be able to build a rubric. And then we have one more unit and then presentation start, I think. So we're getting there. Question?
I know you mentioned, as somebody who lost track of the email and did not fill out the survey, that you would be creating a schedule to try to accommodate all of us. Do
Yes.
you know when that is going to come out?
As soon as possible. So the first question on the outline is which days are you available to be here and which ones aren't? And I can figure that much out because I know how many projects to plan for. So then I can fit it into the syllabus. And I will try my very best to make it so everybody is accommodated, not just for when they can be here, but for preferences. I know some of you would like to get it over with so you can concentrate on other things. Other folks would like to put it off as long as humanly possible. Either of those can work. We'll just see how many of each kind we have. If everybody chooses the put it off as long as humanly possible, then I may have to make some decisions. I also would like, if possible, to try and organize them thematically, like a symposium kind of feel, so people who are doing the same kinds of things or talking about the same kinds of things could go on the same day, if possible, but timing will dictate that as well. So I will soon, as soon as possible is the answer. I will get that ready. So you'll know when you're scheduled, and I'll make sure that you can still participate then. And Zoomers, you will need to show up in person for your presentations. So please plan on that. That's the only way that I think I can make it fair across all of you, because if some of you are presenting on Zoom and some of you are in person, there'll be differences because of that, and I don't want to introduce any confounds into the evaluation process for me or for you. So.
And then,
yes.
One more question about, you said you will use our outlines to build rubrics. Will there be like overarching rubrics and then also like specific to us things?
Overarching for everybody. Okay. Let me, I will show you just as a brief example what I did last year, or 2 years ago, last time I taught this class. The last time I taught this class was the first time I taught this class, to be clear. This is a new thing. So I have some notes about what I might need to change for the future. But for instance, so you have 3 points for setting up an introduction, 3 points for setting up a method. Here's the pieces that would go into that. Results and conclusions. And then we also have some aesthetic things. So this is what I put up last time. I will likely revise it a little bit, but I don't think it will be necessary to give you like more specific feedback in terms of what like your particular model would need, but if you have questions about what would be relevant to present, like if you want to talk strategy, that would be fine. I think that's a reasonable set of things I can help guide. Because if you have a 15 to 17-minute presentation, you're not going to be able to talk about like every single model you tried. So then the question is, what should make the cut and which ones can be summarized? So, okay. Other questions at the moment? Again, this is from last time, but just to give you an example of what it will look like. I'm also hoping to put it into icons so that it's easier for me to fill out rather than the separate Word documents. Okay, what did we talk about last time? What do you remember? Here's a picture. Help you remember. This is slide 9.
Remember that M+ was made by people who don't like to type.
M+ was made by people who don't like to type. That is correct. That's one thing. The mutanes, actually, that's M-U-T-H-E-N with an accent mark over the E. I believe they are Swedish originally. Bent Mutane, longtime faculty at UCLA and his wife. And they have programmers whose children did the diagrammer as a computer science project when he was 12 years old. Yes. That's why M+ has a diagrammer, is because the programmer's son made it. So just in case we all didn't feel bad enough about ourselves already. I tell you that story because for the longest time, the mutanes were like, there's never going to be a diagrammer. Diagrammers are bad. They encourage people to do stupid things who don't understand the models, and then they put it in. And they put it in because it was so good, and they're like, the 12-year-old did it. I can't tell him no. So there's a diagrammer. I don't often use it, though. It's not... it's nice to put the numbers on the pictures, but it's not really aesthetically pleasing. Like, you have to edit it quite a bit to get it into something you want to look nice. I draw path diagrams in PowerPoint. This is nothing more complicated than a series of objects. So, okay, other than the fact that we don't like to type, what else do we remember? And Zoomers, you can play along. I'm watching the chat. What do you remember? Oh, you're thinking.
I know the bar line means defined as, so like Lynn is creating a variable name.
Yes.
Now, why that's different than parentheses version, still don't know.
They kind of do the same thing. So what you're talking about is this bar thing. This is a definition. So what Lin is essentially beta 1. Like, we're creating a new variable that doesn't exist. And what that variable represents is time predicting the outcome in this generic code. So then you're saying, what do you want to do to beta 1? Do you want to predict it? Do you want to have it predict stuff? And so then it's not explicit, but then what happens is you give it a mean, which translates into a fixed time slope. And then you give it a variance, which translates into, starts with an R.
Random effect.
Yeah, random effect variance. So this is your random slope variance right here. This is your fixed slope. And what it's the slope of is defined here. That's why I have a lin and why I have a qua. And why did I type qua instead of quad? Remember that? Not super important, but...
Quad a thing in
Is it a dedicated command? No, it's not. 3 characters, that is correct. So that my code stays nicely aligned is the answer. Because I am of that kind. Sorry, not sorry. So then the other thing, like what you're talking about, and I think we'll see this in an example at some point, Kendall, is like if you had a label like this. So like, for instance, int var. I would need to provide as many qua var. Actually, let's go with lin var as an example. Tim means time, by the way, but it's the same number of characters. There we go. So when you do this, you are labeling what, you are labeling what these estimates are going to become so that you can do math on them. That's what the difference is. So it's this is the roundabout way to do like a lincom. That's the concept. This is also potentially constraints. So for instance, if I only put one word here, then what I'm saying is make all 3 of these the same. So you might see that, for instance, in constraining factor loadings to be equal to each other to fit a Roche model or a tau equivalent model. You'll see this in our examples to make residual variances equal over time. I will use this trick for that as well. So this is either a constraint or a label or both. This is creating a brand new variable to put in your model that you can then predict or predict other things with. Okay, does that help? Okay. There we go. Da-ding. Sound effects. What else? For this particular model, let's zoom out here. What are circles? Latent variables, yep. So each of these circles is a beta that has a mean and a variance, according to this level 2 model. What are boxes? Observed variables. These are columns in your data set. So in M-SEM, which is what we're talking about, multi-level structural equation modeling, that uses long format data. So 1 row per occasion per person. What about directed arrows, like these ones? What do those mean? I know you know.
Slope.
It's a slope. So it goes, the variable that the arrow is starting from is the predictor, and where it's going to is the outcome. How about two-headed arrows, which this is an approximation of at the top? Covariances, yes. So in an unstandardized solution, these indicate covariances. They become correlations if you look at a standardized solution. So standardized means all of the observed variables have been changed in scale to have mean 0, variance 1. So everything is in some kind of correlation metric at that point rather than slope or covariance metric. Is there any reason why I would need to fit this model, back out too far, in M-SEM instead of Elmer or mixed? Nope. None whatsoever. Is it potentially not a great idea to use M-SEM instead for something like this? We haven't talked about this too much yet. What if I have a small sample? Yeah, then this might be kind of a problem because I'm stuck with ML rather than REML. So my variances will be too small, which means the corresponding standard errors for the fixed effects will be too small, which means the p-values will be too happy. Trickles downhill. So why am I making you learn this if this is unnecessary?
Because it's important to have the starting, the answer key, the starting line for where we go.
Yeah, I'm teaching you a new way of thinking about and estimating models. I think it's helpful to start with models you already know to learn the new method of specifying them, and then we'll get to new models. So this type of model right here, univariate, meaning I'm only predicting one y at the same time, does not need this approach. But anything multivariate and anything in which you want to let time-varying predictors be carved up into their variances the same way the outcome is would need these sorts of approaches. Okay. Any questions or things you want to go back over from these ideas? Nope. Zoomers are shaking their heads, eating lunch.
I have a question
Sure.
about the fixed part.
Okay.
I have a little hard time understanding it because like the placeholder, like the beta 1i and beta 2i, they already become like the random part that we had in the circle. So why we still have the two fixed box here for the, because it's like the slope part become random. So it's already represented in that circle. So I just have a hard time understand why we still have the two fixed box for L1 time square and L1, like level 1 kind.
So you're asking why we have these boxes or the arrows going from the boxes?
The box.
The box. Because in this approach, you have time as a column in your data set. And so it is an observed variable that's being used as an observed predictor, and the same is true of time squared.
Okay, because we use that as observer, okay.
Yeah.
Thank you.
Yeah, no, this can be somewhat confusing. The mapping is somewhat non-intuitive. But yes, that is the answer. And this way of specifying it allows you to then have random slopes and cross-level interactions. If you don't want those, there's another way of specifying it that we left off with last time in terms of the example, where the fixed slope shows up in the level 1 model instead. Okay, other questions before we head back to the example? Walk through that a little bit? Yeah. Okay, then let's do that. Do you want to start at the empty model again and work our way up? I should assume you don't have perfect recall of everything that happened 5 days ago? Yep, okay. That tracks. So I'm assuming, I hope I can assume, that all of you are familiar enough with these models that we can focus on sort of how it looks in M+, and we don't have to go back over some of the concepts. But if you want to go over anything, please let me know. By the way, this kind of model, these accelerated time models, that's going to be your next homework. That won't be until after break, though. I'm not going to have you do any homework that involves M-SEM or SEM, though. So you don't have to worry about being held responsible on a homework assignment for those models, but I'm guessing most of you will end up using that for your projects based on what you want to do. The reason I didn't do a homework on it is because I didn't think it would be fair, because some of you have had SEM before and some of you haven't. And for those of you who've had it before, this is going to be a lot easier, to be quite honest. Like, it takes a minute, so I wanted to kind of not have an unlevel playing field with respect to that. So empty model, then. This is what the code would look like in Stata or our Elmer's package. Here are the results so you can compare the numbers. In M+, so remember you have to tell it where your data are. Can your data have labels at the top? No, they cannot. So copy the first row out of your spreadsheet and paste it in here instead, and then delete the first row. And it needs to be either a CSV file or a DAT file. I like CSV better because when you double click on it, it opens in Excel and you can see quite readily what it should look like. Names then are the columns in order in the file. I would recommend subsetting your data to just the needed columns so you don't have to end up typing as much. Each of these needs to be 8 characters or fewer. If you have a name that is longer than 8, what happens is it truncates it to 8. So if you had variables that were like the last letter or number separated them, then it would get really confused because it would think they're all the same variable, like the first 8 characters match. Use variable. What happens if I forget this? It uses all of them. It will try to put every single column into your model somehow as just boxes floating out in outer space. Missing data, I am superstitious. I always fill in a code, but technically speaking, you can just have dots. And then M-SEM options more specifically. What is your level 2 identifier? And then between and within is where we're going to stick predictors whose variance should exist only at one level. So it's not going to try to split it into between versus within if you put them on these lines. Type equals 2-level random is what we're sticking with. We don't need the random part just yet, but it's coming very shortly. And I'm using regular flavor maximum likelihood rather than the robust version so that the results will match as closely as possible to those of SAS, Stata, and R. Okay, then the model part. Within, that's your level 1 model. Everything underneath it is that. At this point, this is an empty model to partition the variance and recall, so I'm just requesting its residual variance at level 1. When I type recall at level 2, I'm requesting its random intercept variance. So when you see this word, it's really referring to the 2 circles. It's referring to, hang on, let me get back to the corresponding picture. I don't think I have one. Yeah, it's referring to that circle and that circle, the level 2 intercept and the level 1 residual. That's what you're actually talking about. And then anything in a bracket is a mean or an intercept. If it's something that's being predicted, it's an intercept, so that will be our fixed intercept. So that's not so bad, right? So along with the use of regular flavor maximum likelihood, you'll note there's no denominator degrees of freedom. So these are all z-tests and chi-squares, assuming infinite sample size. Yet another reason why small samples are probably not a great idea within this framework. And did the mutanes label these things for you? No. If you're looking for this column in your output, you're not going to find it. This is me being nice. All right, we're going to skip the SEM part for now.
Hey, Lisa.
Yes. Go to the next one.
I know this is kind of a weird question, but you keep saying not to use it with small sample sizes.
Mhm.
Is there like a general rule of thumb that like this is not it, like you need to have this or more?
At level 2, I think 50-ish is where things start to become not as problematic,
Okay.
but it depends on how complex your model is
Got
as
it,
well.
okay.
So generally speaking, the more stuff you're trying to do at the same time, the more people you will need to do it.
Okay. Thank
You can always give it a try. You'll find out the hard way if it doesn't work. And there's various tricks I can help you with if it doesn't work for your data. So we will not admit defeat. We will not stop until M+ cooperates somehow. All right, 1B then. I am adding in 2 fixed effects only. So note these only have fixed slopes for age and age squared. So this is actually time and time squared. I'm just writing it in a way that describes how time is being created. So then it would look like this in mixed, look like this in Elmer. Here's the answers that we're going to find in the output. So then a couple things. I screwed this up last time, so how about I don't screw it up this time? Would that work for you guys? So I am making time squared right here. So you cannot define interaction terms among variables measured at the same level on the fly. You have to physically build them as a variable. So define is a way that you can do data transformations. This one looks fairly straightforward. You're just squaring this column. I then list time and time squared in the use variables because I'm bringing them into the model, and time squared has to go last or it will yell at you. So it has to know which variables that exist you want in your model, and then it looks for the ones that you've defined here. Time and time squared also go onto the within statement because we want to use them in the level 1 model only. We don't want them to try to figure out how much of time and time squared would be residual versus random intercept. We don't want it to do that, so we're leaving it there. So note that recall, for instance, is in neither of these places. That's why recall then gets a random intercept variance and a residual variance estimated. Okay. Now, your question, Kendall. No bars. This is one way of specifying level 1 fixed slopes. So I don't have a name and a bar, I just have the slope. So what's going to happen is that this way of specifying it will result in those fixed slopes being put in the within model part of the results. Because that's what they are. They're within person changes. I cannot then do any kind of cross-level interaction with time, and I cannot do random slopes if you do it this way. So this is one choice, but it's limited. So I'm adding in 2 fixed effects, 2 fixed slopes. They then show up on the within model. On the between level, recall mean is still labeled as such because at the between level there's no predictors. Recall variance is labeled as such for the same reason. So what would I call this number? 10.6. What does the variance of recall at the between level translate into?
The level 2 variance.
Level 2 variance, which one?
U sub
U?
0.
Yay! U sub 0. There's only one U in this model, so that's what it would have to be. So yes, 10.6 is what we would call the random intercept variance. That's what the variance of recall at the between level means. How about 4.9? What would I call that? Residual variance. Yep. It's level 1 residual variance, and it's also leftover. So note in the empty model, go back to that for a second. far back, it was called within level variances because it was unpredicted. So this, even though it's labeled as variance, I would call that level 1 residual variance specifically. Once it's predicted by time and time squared, then it changes to be residual variance, meaning leftover. Residual of the residual, essentially. Okay, questions thus far? All right.
Why did we not have recall in this recall at all? Is that like the baseline, like expectation?
I'm not sure what you're asking, but let me revise. Let me scroll back up to the formula. So here's my between model. I have 3 fixed effects and only 1 random effect. Does that help? Okay. Yep. So note where the intercept is. It's this right here. The intercept shows up in the between model because it has a random intercept with it. So everything moves to the between model when you start making things random. Okay, that's skipping that for now. Okay. We're adding now cohort effects. So this is age at baseline is going to enter as a moderator of the intercept as a linear effect and a quadratic effect. So I'm allowing a non-linear effective cohort essentially and predicting where you start out at time 0. And I'm adding a linear effective cohort and predicting linear change over time. So 3 new fixed effects as part of the story. So that is straightforward to do with just colons for interaction terms or hashtags if you're using Stata. And then plus it's a little trickier. So first thing I did was create my age at baseline centered version because I had not done that. And then I created a squared version of that. Those 2 new variables then go onto the between line. So I'm telling it age at baseline is a level 2 time invariant predictor. Let it exist on the between model only. Don't try to carve it up into level 1 versus level 2. And then I have these 3 new terms included in the used variable as new parameter or new variables created by define. Okay, with me so far? Now, how do we do this? Here's a mix and match approach. Here's my friend Lynn. That is a name. That is beta 1. So I am creating a new variable that will be included in the model called beta 1. What it is the slope of time predicting recall. I needed to do that because I wanted to have cohort predict this linear slope as a cross-level interaction. So because I have this term right here, I have to use the placeholder notation where I create the slope, name it, and then refer to it in the level 2 model. In contrast, stay here for a minute, I don't have anything predicting beta 2. So that one can stay in the level 1 model if I wanted to. And I've actually seen convergence differences when you do things one way versus the other. So recall on time squared is just the fixed quadratic slope that's not moderated and it's not random. Lin is going to be the linear slope that then gets moderated in the between model. So in the between model then, altogether, zooming in all the way, these things are your fixed effects. This one, for time squared, is going to be shown in the within model instead because of the way the code is written. Lin at 0. People who've used M+ before, what am I doing? Thinking faces, like, oh, I've seen this. What does it do? Not to be confused with Levon, whose code is exactly backwards in terms of what is fixed and free. Fixing variance, ding, ding, ding. Fixing it to what? 0. So that's a roundabout way of saying I did what?
Did you turn off like any random slopes for that?
Yep, I turned off random slopes because it's on by default. So when you create a new latent variable like lin here, it automatically thinks you want a fixed effect and a random effect variance for it. If you don't want either, you got to shut it off. So in this model, I do not have random slopes yet, so I shut it off. What is this line doing? ATO84 is cohort, age at baseline, centered at 84. What's happening? Remember what on means?
Age at baseline is predicting both of those?
Yes, it is. So age at baseline predicting recall. What am I talking about more specifically? Because recall is the name of the column in the data set, but that's not what it means in this context. Any guesses? When you see the name of your variable in the between level, that's a random intercept. So this is the main effect of cohort on the intercept. So that would be gamma 01, I believe. And likewise, the main effect of age squared at baseline on the intercept is right here. This inside part, what would I have called that last week or last semester?
Interaction.
It's an interaction, but what kind? Is that cross level? Excellent. Yep, this is a cross level interaction. Because what I'm doing is predicting beta 1, that when you see lin, think beta 1, with age at baseline. That translates into this term right here, predicting beta 1 with age at baseline. That is the reason why I needed to use the placeholder notation where I first define beta 1 and then I'd say what happens to it, is because of that cross-level interaction. I think I hit all of them. Questions on any of the code? All right, so here's where it gets a little interesting, trying to find what's what. I helped, because it's not obvious. So the first thing that shows up is recall on times squared. What would I call that last week? Actually, about 2 weeks ago. In multi-level modeling terms, what would I refer to this as? Recall on times squared.
Is that the fixed time square slope at a particular point, like times 0 probably? Question mark?
First half of it is correct. This is what I would call fixed quadratic time slope. But because there's no higher order term, it's not specific to time 0. If I had a fixed cubic slope times to the third power, then the quadratic slope would be conditional on time 0. So yeah, I would call this the fixed quadratic slope. And it's in the within level output because it does not have anything past this fixed slope. It doesn't have a random slope. It doesn't have cross-level interactions with it. So it shows up here because I wrote the code this way. Here's my level 1 residual variance. Unfortunately, even though you can write your syntax to request things in a logical order, M+ will turn that order into whatever it wants to do on the end. So finding your results can sometimes be a bit of a scavenger hunt. For instance, the very first thing it puts, that's my cross-level interaction. I know, like, why would that be first? Because I didn't make the rules. So this is how age moderates, how age at baseline moderates the linear time slope. Where is the linear time slope that it's moderating? Scavenger hunt time.
Is that the gamma 01? Is that the under recall? The first one under recall?
This one?
Yeah.
Nope. These are cohort effects on the intercept. So these would be gamma 01 and gamma 02. The question was, this is the cross-level interaction of age moderating the linear time slope. Where is the linear time slope it's moderating?
It's the lid under intercepts.
Yeah, the intercept for Lin. So that intercept means it's being predicted, but the mean of the latent variable Lin, which is beta 1, is the fixed time slope, linear time slope. So that's why we have two things under intercepts. We have the actual, what I would call intercept, fixed intercept, and then we have the intercept of the beta 1 level 2 equation, which is the fixed time slope. So now we can see that there is a positive linear time slope at time 0, because of the quadratic, I have to say that, and it is more positive in people who started older by a little bit. Likewise, the fixed intercept, this would be the expected recall at time 0 for somebody who started the study at 84. For every year older you are at 84, that predicted intercept would be lower. However, that effect sort of is diminished at older ages. So the linear effect is being compromised, slowed down by the positive quadratic, but it's very little. Okay, residual variance for recall in the between model. What's that? I know, the residual variance is in the between model in this output. Yep, that's leftover random intercept variance. So residual in the leftover sense, not in the level 1 sense. This is why I knew I'd need soda today. Last but not least, what's this thing? The residual variance for Lin. It's the random slope variance we turned off. So when you see this, 99999, that means this is a fixed parameter. These are not numbers. It's filling in essentially a missing value code because you can't divide by 0. The standard error is 0 because there is no estimation error. We said it's 0, the end. So when you get into these models and you're setting up something really complicated, before you look at the output in terms of interpreting your numbers, I would literally go down this list and make sure everything that you wanted on is on and everything you wanted off is off. Figure out if it interpreted your syntax correctly, because sometimes it will invoke defaults that you may not know about, and that means you're turning extra things on that you didn't request. Okay, how we doing? skipping SEM for right now. Let's add a random slope. A random linear slope to be specific. There's the output for comparison's sake. All right, so up here, if I want to add just a random slope of a variable that I've already put in the model, do I need to change anything in this? Nope, this is all exactly the same. In here, what have I changed? To execute a random linear time slope variance. Should be 2 changes.
Len doesn't have the at 0 anymore.
Yep, it's not at 0, which means go ahead. Be whatever you want. That's 1.
Is that a default?
Not a default. Not a default in M-SEM. It is a default in SEM, though. Yep. You can't make this up. Yes, so the word with, that's a 2-headed arrow. That's a covariance. So I am allowing a covariance between what and what, specifically. Recall with Lynn, I would have called what 2 weeks ago?
So it's the covariance between the random intercept variance and the random slope variance per term?
Yes, to be picky though, it's not between the variances, it's between the random effects. Like the variances themselves don't have covariances, but the random effects do. So yes, this is the analog of saying covariance unstructured in Stata and type equals UN in SAS for the G matrix. So I am adding the covariance between the random intercept, that's what recall means right here as our outcome, and the random linear time slope, that's what Lin means. Everything else should be the same.
Sorry, could you go over again what the first one was? I was in the wrong place in my notes.
Yes, so the first change is right here. We took off the at 0, which means let it be what it wants.
Yep.
And the second change was adding the covariance between the random intercept and the random slopes, which is not a default. All right, let's go find him. I tried to help. Here's one. So that's my random effect covariance. My new random slope variance is down here. So in this world, you will most often see people be like, hey, it's significant, therefore I have a significant random slope. Not technically the rightest way to say that, but it's very, very common. So we would normally do a likelihood ratio test to establish whether or not we need this slope and the covariance with the intercept. In this context, people often don't bother. For this kind of result, I would say it's going to come out the same either way. It's really just for borderline cases that it would make a difference. The issue is that variances don't have a normal distribution. And the closer that they get to 0, the more unnormal it will be because there's only one side that's possible. So a walled test like this that assumes a 2-sided sampling distribution can't be right. Once you get your variance far enough away from 0, then it does have approximately a symmetric distribution, and it would be reasonable to look at this. Okay, I think that's the last one. No, it's not. This is the interrobang one, where we added a random slope for the level 2 predictor. And Stata was like, maybe? I'll give you some incomplete output and call it good. R was like, absolutely not. M plus was like, I'll try. So it wanted me to change the way that the estimator is working into algorithm equals integration for some reason. And then it gave me this very angry capital letters. Like, you know how people yell at you in like text or emails if it's capital letters? That's always my reaction when I see this. Like, I'm sorry, I didn't mean to make it non-positive definite. It's not my fault. So it's just like, no, 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 but okay, here's your results. And there it is. So my weird random slope of a level 2 predictor to introduce intercept heteroscedasticity, not significant, but not really sure if we can trust it or not. There, that's the last one, I'm pretty sure. Yep, that was it. So other than everything being an intercept and a residual variance, it's kind of the same. It's the labeling conventions that change, not really the ideas or what they mean. Any questions? Let me go back to models that don't suck, these ones. Are you ready for the single level SEM side of this? The third possibility? For those of you who want to build measurement models with latent factors or do factor of curve of factor model things with multivariate space, you're going to have to do it this way. So we'll change over into that format. Okay. Picking up on, this was the end of the M-SEM part, slide 12, switching to the regular SEM. So SEM or SEM? Either way, Europeans tend to say SEM. Americans tend to say SEM. The one thing you should never say, though, is SEM model. Like an ATM machine. That is like, tell me you don't understand SEM without telling me you don't understand SEM model. So don't do that. And you'll know how tired I am if you hear me say that. That's a good indicator. That's one of my tells. That one, and if I get like there, and there wrong when I'm writing something, I know it's time to put the computer away. Like, too much. So for those of you who've had SEM before, this may seem relatively straightforward. However, it's conceptually backwards in what the loadings do and what the variables do. And that is the switch that folks had the hardest time with 2 years ago. So I'm trying to make it easier this year, but we'll see how it goes. So the world of SEM typically would have something called a measurement model, where you have a row of boxes, which are indicators of some kind of unobserved trait, and then you have slopes of that trait predicting each of the boxes. But for whatever reason, we have to change the notation system completely in this world. We can't just call it a slope. So these things right here, these are lambdas, these are your slopes. F stands for factor. I'm not going to use Greek letters I can't pronounce or draw. F stands for factor. This is your latent trait, latent construct, thing you believe exists that you can't measure directly. Theta, true score. What other ones am I missing? Latent variable, latent construct, latent factor, true score, theta. Any others? There's a whole list. Trait, latent trait. Missed that one. F. This thing mu here, that's an intercept. So this would normally be like a beta 0 in a regression equation, and this would be a beta 1. We changed the terminology. The intercept means the same thing, though. It's the expected response to this variable when f is 0. So the definition of it has not changed. E has not changed either. E is how wrong the model is for that particular observation, error. So in terms of what would normally be estimated for each item in this context, we would have an intercept. We would have at least one slope relating it to a factor. You can have it relate to more than one factor if you wish. And then the variance of these E error residuals across people for that item. The structural model then would be composed of the factors and their relationships. So each of these factors needs a mean and a variance, and if there's more than one factor, you can have them connected with two-headed or single-headed arrows as you choose. That's known as the structural model. So f doesn't exist, it's in a circle. That means we have to give it a mean and a variance to have it exist. In traditional measurement models, we would often do that by constraining the intercept or the loading of an item. In growth models, we're going to have a very different set of constraints because what we're trying to enforce would be the interpretation of this latent variable as either an intercept or some kind of slope. So we're using constraints to say, hey, I know this thing is imaginary, but make it this. So here's a random linear growth model in the world of SEM. First thing you'll notice that's different relative to the multi-level version of SEM, I've got 5 boxes here instead of 1. This is wide format data. So we're changing it so that it's 1 row per person, and each separate occasion for each separate variable is a different column. So I have Y0 through Y4, where the numbers are not in subscripts to emphasize that this is different columns as opposed to different rows within the same column. So most of the differences in the code is just because of this difference in data structure. It makes it look very different, but it's not. So here's what we would call individual intercept, individual slope. Individual intercept, individual slope. The mean of each of these is the fixed effect. The variance of each of these is the corresponding random effect variance. Now we write it like this, where the variable comes, or the latent variable, beta 1, comes first, and the observed variable comes second. Note that I have time in orange here because it matches the orange. Time is implemented by constraints on factor loadings. So here's how we get from this to this. First off, we need 2 latent factors in this model. We need 1 for the intercept and 1 for the slope, whereas previously we just had 1. So that's the first step, make us 2. So I'm writing this in the measurement model notation to start with, what I would call these things. The first thing that I have to do is shut off each of the intercepts that would be normally there for each of these boxes. I'm shutting them off. The reason for that is because I want to move all of the information about what the mean is at that occasion up so that the factors take care of it instead. So these intercepts right here, what I put in the little boxes, they are attached to a stupid triangle in a lot of SEM diagrams. That's the way that they get into the path. I hate that thing, so I don't ever use it on purpose. These are all going to 0. That's step 1. Step 2 is to combine the fixed and random effects into one factor, rename them, and reorder them. So I'm rewriting this equation so that's in the right order to match the SEM version. So I have beta 0 times the variable. So there's no variable here, right? Beta 0 is just hanging out by itself. Another way of saying that is that the variable that it would multiply is a column of 1s. So I have the 1s on here connecting beta 0 to each of these observations. That means I am creating a random intercept. Now, I had beta 1 times time up here. The loadings for this factor are going to hold the values of time because I have columns instead of rows. There's no information in the data set about what occasion it is. So I have to input that into the model some other way. So what I used to call fixed and random effects, we now call factor means and variances. But these time loadings here, that's the tricky part. What used to be a variable in your data set is now gone and is replaced by instructions within your model for what these values should be. So the reason I can say this imaginary thing is a linear time slope is because I set up the loadings to make it that way. Does that make sense? So if I look at the interpretation of the intercept, that is the expected value when all predictors are 0. The time slope loading has a 0 contribution at this occasion. Therefore, the random intercept is the predicted outcome at y0. And this assumes equal intervals. If, let's say, the last occasion was 2 units in time apart, what should I put here instead of a 4? A 5, yeah. So you don't have to have equal interval data, but the numbers that you hold these loadings fixed to need to appropriately catalog the differences in time. Oh, not that yet. Last but not least, I cheated for the sake of time. So I would normally have 5 little e circles down here for the level 1 residuals, and I want them all to have the same variance, so I just put them all in this sort of rounded box to cheat. I got yelled at during review for it, all right? I've already been chastised enough, but it's cleaner and it makes it easier. So this is actually a constraint in the SEM world that we don't normally think about. I am saying that the leftover variance at time 0, 1, 2, 3, and 4 is all equal. That's a diagonal R matrix. What Elmer does as its only choice, and what the default is in every other MLM program. Equal variance over time. In SEM software, though, the default is not this. It's to let all 5 of these have different level 1 residual variances. A heterogeneous R matrix on the diagonal. I don't particularly like doing that as a default. The reason is that when you introduce a random slope, what are you doing to the variance over time? What are you saying about the pattern of variance over time at that point, if you add in a random time slope? It changes. It changes in a particular way, actually. It changes in a quadratic fashion, where it will be highest towards the ends as people spread themselves out more, growing at different linear rates. So this is already creating different model predicted variance at each occasion. If you let the residuals have different variances at each occasion, it's somewhat redundant with what's trying to happen here. And I have seen convergence and interpretation issues pop up when you try to do both at the same time. So I would typically start with homogeneous variance, force all of these residual variances to be the same, see if the model doesn't like it. Like if there's misfit and it says, no, actually you need a lot more variance at time 4, okay, let that one be different. Make the others still be the same. So the choices that we were locked into in the MLM world with alternative covariance structures, so I'm bringing that topic back. I know you asked me to review it like a month ago. It's coming back. Whoever put that on the review question. The choices that you have in MLM software are a lot more limited just by what is built in. So like we had homogeneous variances or heterogeneous variances, right? All the same or all different. Those were your only 2 choices. I could have whatever I want here. So I could have 4 be different than the others. I could have 0 and 1 share one and 2, 3, 4 share another one. Like I can do any combination that I want. Likewise, do you see any bendy arrows, 2-headed arrows among the boxes here? Nope. That is consistent with the idea of no residual covariance. So zeros in the off diagonals of the R matrix. What if I want to say occasions that are next to each other should be related? Could I do that? Yeah, so if I thought I wanted to have, say, a Toeplitz pattern, where I have lag 1 relationships only, I add 1 arrow between this one and this one, another between here and here, another between here and here, another between here and here, and I say, hey, make all those the same number. That creates a homogeneous Toeplitz across the lag 1. And I could do lag 2, I could do lag 3. So on the Piles of Variance website, under the M+ section for these models, I actually do have the SEM code to do this because you can't do this in M-SEM. Not with covariances. The problem is that there's no way to tell it to relate things that are at different rows of your data set in M-SEM. You can have them predict it, like you can fit lagged fixed effects, but not lagged covariances. It's not possible. So if you wanted to do any kind of covariances among your residuals at different occasions, it needs to be done in wide data where it has access to all of that at the same time. Okay, questions so far? So one of the problems with R-only models is also illustrated here. Any thoughts about nailing these loadings down to exactly 0, exactly 1, exactly 2, exactly 3, exactly 4? What would I have called that 2 weeks ago? Starts with a U. This one starts with a B. Where I'm going starts with a U. What if people don't cooperate? Taylor, I'm going to call on you. You study babies, right? Are your babies very diligent in keeping their appointments?
No. Or they come and they don't sleep.
No, that would happen too. Do the babies ever get sick and they have to cancel and reschedule?
Yep.
Yep. So even if you want the baby to come in at exactly 6 months old, can you make sure that happens?
No.
No. So then what happens to your baby who was sick and had to come back at 8 months instead of 6 months? What's their factor loading going to be?
I don't know, it's gonna get messed up by then, because
It's going to get messed up. Yep. Okay, you're off the hook now. But yes,
We're talking about
balanced.
like balanced.
That's what we're talking about. This is balanced time. And if your babies come at the wrong time, you got to tell it, actually, this baby needs a 1.2 here. Can you do that instead? And this baby needs a 2.3 here. You can, if your software lets you. So the term for it, what you need to search for in documentation, is a definition variable. Practically speaking, what that entails, again in wide data, is a set of columns for when exactly time 1 was, when exactly time 2 was, and all the rest of the occasions. You would then say, hey, can you take those columns of actual times and for each person replace these fixed loadings with the one that corresponds to their exact observed time? So individual specific patterns of factor loadings that correspond to exactly when people were measured. That's how you would have to implement unbalanced time. OpenMX will do it in R. M+ will do it via t-scores, and I have yet to find another package that does it. I could be wrong, but I have not found it. So if you have unbalanced time, you're going to either have to pretend like it's fine or use M+. Yeah. Here is the mapping of SEM and MLM. Also reviewing matrices and such. V is what we called it. The model predicted variance across occasions in people. It's going to be sigma in SEM land. Z is a design matrix that gives the values of the predictors that have random effects. That is represented by the loading matrix in SEM land, because the loadings are the time values. What we call G, level 2 random effect variances and covariances, shared across everybody, whereas Z is person specific, whatever values they happen to have for their time observations would go in here. That corresponds to either phi or phi. Do we have a preference? No? I don't care. That one. G is easier. That's what I know. But this is the matrix of factor variances and covariances in SEM land. Then we have a Z transpose. So these three work together to get the matrix to the right dimensions to be added to R, which is psi. The only reason I know this one is because I was the faculty sponsor of Psychi when I was at Nebraska Psychology. That's the only reason I know this. So, that is R. So there is a 1-to-1 mapping here. It is literally the same thing with different letters and terminology. So now we can see some code. So any questions about the mapping part? So level 1 residual variance is the variance of the boxes here. Level 2 random effect variances and covariances are in the circles. What used to be a column of time is now represented by the loadings as constraints so that we can say, I want this to be a linear slope specifically. The code looks a lot different because rather than referring to just like y and meaning all the observations for y across occasions, we have separate boxes for all the different occasions of y. So we have to refer to the separate boxes. So here's my random linear model. The first thing I have, and note there's no between within. Okay, that's gone. And honestly, that's part of the problem why people screw up these models so much, is because they're not thinking in terms of levels. Here's a new one. By means factor loadings. These can be estimated or they can be fixed. In this case, I have fixed them. So the loadings for the intercept factor are all fixed to 1. The loadings for the lin factor are fixed to the value of time relative to the first occasion, assuming this would be an equal interval example. Then we have the fixed effects in the brackets. We have the random effect variances, and then we have the random intercept and linear covariance, which is a default now. Because reasons. Then the other constraints that we have to do, we have to shut off the intercepts for each of our observed variables. So all of their information in terms of their means and variances over time are being captured up here in the level 2. Then what's left, residual variance, occasion-specific variance, is this box right here. And so this is an example of a label and a constraint. So when I type resvar, that's my label for what it is. 8 characters or fewer, otherwise you can type whatever you like, even a number. That is saying take the level 1 residual variance for each of these occasions and force it to be the same. So I'm creating a diagonal R matrix. Quadratic. Tell me why I can call this quadratic and be right. What makes this interpreted as a quadratic time slope specifically?
The way you did your factor loading?
Yep. Time squared. I'm forcing the interpretations here. What about, do I have a piecewise one? I think I do. I don't have a picture. Nope, I don't have a piecewise one. What if I wanted a piecewise model instead? Could I do that? Yeah. So like for instance, if I wanted a change that went from 1 to 3 and then a separate change that went from like 3 to 5 here, I could go 0, 1, 2, 2, 2, 0, 0, 0, 1, 2 on the loadings, and that would turn this into a piecewise model. So you are still in charge of enforcing the interpretation of these time trends via latent factors via the loading patterns. And these arrows connected to the bar across is the lazy person's way of saying all possible covariances among these. I like that. Keeps it less cluttery. So we are enforcing the interpretation of these via the constraints. By the way, those of you who are familiar with IRT and S-EM land, in that class I often say theta is a random intercept. This is why. Because this method of identification fixes all the loadings and estimates the variance. Alternatively, I could constrain all of these loadings to be equal and fix the variance to 1. And that's a more traditional 1PL or Roche model. So theta is a random intercept if you're fitting a Roche model. Here's the proof. Questions or comments? I would do a thumb check, but I'm kind of afraid to know the answer. Don't ask. Don't ask questions you don't want the answers to is a good strategy in life.
Is there one way of this is better than the other, one way that's easier and cleaner to understand, or which one do you prefer to do? Is it dependent on the question? When do you choose?
Question is, how would you choose which one to do? It depends on the data and it depends on the question. If you have unbalanced time, I would probably try to avoid this. If you're interested, like if each of these boxes is actually a latent factor measured by other things, this is the only way that I know how to do it that would allow you to actually test a longitudinal measurement invariance as part of that question. If you are not sure what kind of time function you need and you want your data to figure it out, let me fast forward for a minute. This kind of model, I have what is known as a latent basis slope. If you want to do this, this is only possible in single level SEM land. So I have a 0 for my first loading, a 1 for the last, and then I have stars to indicate estimated. So what this does is try to figure out how much of the change would have happened by each occasion and express it that way. So it's essentially relabeling your occasions as different numbers. Latent basis is a good choice when you have some nonlinearity, not very many occasions though, and it looks like the model can only support one kind of random slope. Then a random slope of this thing might be a more parsimonious alternative than like a fixed quadratic random linear or something like that, or God forbid a random quadratic. So yes, there are reasons why I would do one and not the other, but I think as we go through different examples, then you'll get a chance to see like when they're equivalent and it doesn't matter versus when one would be a better choice. I don't think there's like a science to it, it's more like an art. Yeah. Other questions? All right, then how about I let you go for today? Go enjoy the rest of your garbage day. I hope it's not raining, but I did bring my umbrella, so it's probably not going to now.
Thank you.
Yeah,
For your sacrifice.
you're welcome. All right, let me know if you need anything. Hope to see you Thursday. Thanks for being here. Bye for now.